Hello everyone, we are from Team Fantastic 4.0 and today we'd like to present about our project, the SecurePath AGV rover. So let's start off with a simple introduction. I'm sure all of you are familiar with pickpocket or maybe theft cases or even kidnapping cases in retail environments. So what happens when these actually occur? The first thing we will do is we will look for an authorized security personnel who will in turn look through their security systems, which in this case would be CCTV footages to try to locate the culprit. But by the time they locate the culprit, they will have been long gone by then. So this actually poses as a very high potential security risk in retail environments even today. So take 6-year-old Albertine Leo for example. She was actually abducted in Johor and last seen at the Bon Odore Festival at the shopping mall Eco Galleria at Iskandar Putri, Johor. She was finally found in Selangor by the police. On the other hand, there are also medical emergencies in retail environments. Take a heart attack or even minor injuries, for example. People actually struggle to locate medical first aid kits, even though they are all around the mall. So this might delay the time of treatment for the patients. So in this case, which happened in 2023, Mr. Tiwari is actually seen collapsing and falling at the floor in a mall. Although people gather around to check on him, he still passed away due to a heart attack, which highlights the importance of having a emergency response unit that is highly accessible at all times in retail environments. So this moves on to our problem statement. There are actually a lot of flaws in coverage for in our current security system. Although we have all these cameras and also patrols all around the retail environment, we are unable to cover every inch all the time due to human errors or even placement of cameras. There's also a lack of integration with our current security system, where inefficient communication during security systems fail to provide timely or clear information to all relevant parties. Finally, there's also a lack of effective emergency response plans. People are actually wasting a lot of time in resolving emergency situations. Even if there are emergency protocols at hand, people are bound to neglect them. Therefore, the aim and objective of our project is to introduce and develop an autonomous security robot that can effectively respond and handle routine or emergency situations. So the SecurePath AGV rover covers the following functionalities, which includes security surveillance and monitoring, medical or security emergency response, and also enhanced customer and staff interaction. Let's talk about our methodology for our project. Our methodology for our project includes the following, which is the SLAM navigation, danger detection, user-friendly chatbot, and also the automatic medical dispensing system. So, hello everyone, my name is Gochuk Fan and I would like to talk about my part on SLAM navigation. Now, the design process of the SLAM navigation revolves around the nav2 package, which is used for navigation application in ROS2. The nav2 stack revolves around the behavior tree navigation server, which consists of the recovery, controller, and also the planner server. This server relies heavily on real-time sensor data, which in this case we'll be using a LiDAR sensor and also wheel odometry. By using a looping algorithm, the waypoint follower node constantly provides a target post to the navigation server, and this navigator server in turns will provide a velocity command to our actuators, which is connected to a motor driver. In this case, we are able to produce a final result which consists of autonomous patrolling capabilities combined with obstacle avoidance. However, there are still some flaws in our current navigation structure, which can be further enhanced by integrating multiple sensors. In this case, we are talking about an inertial measurement unit, or also known as a IMU sensor, to prevent wheel drifts. And we can also include a bump sensor, which is used to detect obstacles which are out of the sensor range of the LiDAR sensor. You, with the integration of these multiple sensors, we are able to provide a more accurate localization and navigation uh, structure, which results in an enhanced autonomous navigation capability. So that's all for my part on the SLAM navigation. Thank you.